Hello, I am Arpan from Foundation Academy. In this video, I am going to discuss about the questions from electrostatics of your February attempt. For more queries, contact at the email address given here. So now we will start with another question. First question on 24th February shift 1. A cube of side A has a point charge plus Q located at each of its vertices except at the origin where the charge is minus q. The electric field at the center of the cube is, we have to find the electric field at the center of the cube. So let us draw the cube again. All the positive charge lies, all the positive charge lies over here, plus q, then plus q, plus q, plus q. Only one vertex lies the negative charge minus q. Now all the positive charge, this charge and this charge will repel each other. Similarly, this charge and this charge will repel each other. All the positive charge, opposite positive charges repel each other and they will cancel out. Only this point charge, this minus q charge and this positive charge will attract each other and this will give force at the center of the they will give the electric field at the center of the cube. So we'll find the magnitude of electric field at the center as E4 plus magnitude of E7 if we consider it as fourth vertex and this is the seventh vertex. Okay, one, two, three, four, uh, 5, 6, 7, 8. Okay, so the electric field will be generated from this fourth vertex and this seventh vertex. Uh, Everyone knows the formula of electric field from electrostatic 1 by 4 pi epsilon naught capital Q by. Now, what is the position vector of this point from the origin? How will we calculate this? So if we draw a naked cube, then what will happen? We have to know what is the position vector. So first of all, we'll find this by Pythagoras theorem. If this is the side A and this is side A, this A B will be how much? AB equals to root over A square plus A square, that is root 2A. Next, this AC, if this is AC, then this AB square plus BC square will get this AC. So AC equals to root over AB square plus BC square. Now AB we have found that AB we have found root 2A, so root 2A whole square equal plus BC. Now A square gives root 3A. So this AC is root 3A by 2. So the distance of this point from A will be root 3A by 2. So Q by root 3A by 2 whole square. Similarly for E7 it will be same 1 by 4 pi epsilon naught root 3 Q by root 3A A by 2 whole square, right? So it will get double, that is 2q by 4 pi epsilon naught root 3a square. It will be 3a square by 4 or 2q by 3 pi epsilon naught a square, right? Now, if we write this electric field, now if we write this electric field in vector form, then E vector equals to minus of mod D into r cap equals to minus what will we have find over here, the magnitude of electric field as 2q by 3 pi epsilon naught a square, and this r cap will be, if we consider this as unit vector, then x cap plus y cap plus z cap whole to the power root over 1 plus 1 plus 1, that is minus 2q by 3 root 3 pi epsilon naught a square x cap plus y cap plus z cap. So the answer is option 3. So we head towards the next question on 24th February shift 2. Two electrons each are fixed at a distance 2d. A third charge, proton, which is a proton placed at the midpoint, is displaced slightly by a distance x. This x is very smaller than d, perpendicular to the line joining two fixed charges. Proton will execute simple harmonic motion having angular frequency कितना होगा उसको निकालना पड़ेगा. तो हमको क्या करना पड़ेगा, एंगुलर फ्रीक्वेंसी निकालना पड़ेगा, where m is the mass of the charged particle. Options are given. Now let's start. This is one electron, this is one electron. They are separated by a distance 2d. Say this is the midpoint. This is d and this is d. Right? So this we place the first of all we will place the proton at the midpoint. Now we will displace a distance of small x and we keep this proton over here, which is of positive charge. Now this proton will have an electrostatic force with these two electrons, that is the Fr and this the Fr, right? So this Fr will have two components. One will be Fr cos theta. If we take this angle theta and this angle with theta. Similarly for this force Fr cos theta. So this Fr cos theta component will cancel out here, and this Fr sin theta component will be this side for both of this, that is 2 Fr sin theta. For this Fr also, Fr sin theta component will be in this direction, and this Fr also, the Fr sin theta component will be in this direction, right? So this proton will undergo a restoring force towards its midpoint, that is it will undergo an SHL, right? So this restoring force will be on proton. If you consider it as Fr dash, then it will be 2 Fr sin theta, this 2 Fr sin theta, right, equals to 2 into what is the formula of Fr, force between two charges, equals to, from Coulomb's law we can say that F equals to 1 by 4 pi epsilon naught q1 q2 by distance between them is by r square, that is 1 by 4 pi epsilon naught q square, as both the charges of protons and electrons are same. q square, we consider it as q, and the distance between, if this is x and this is d, if you consider it as r, then r will be from Pythagoras theorem x square plus d square, right? So x square plus d square, this will be root, and this is whole square, and sine theta will be x by r, that is x by r in, will be x square plus d square whole to the power half, right? So this will be considered as q. If we solve it, then q square x by 2 pi epsilon naught dq, where x is very smaller than t, right? Equals to kx. If you consider x, for simple harmonic motion, we consider a constant k. If we compare it with this effort dash, then now if we write the equation as kx, then we can write k equals to q square by 2 pi epsilon naught dq, where x is very smaller than t. So we can neglect this x term from this equation, and we can write directly as dq. So next, if we compare these force with SHM equation, then we can write from SHM, we know that F equals to kx, where k equals to force constant, and it can be written as m omega square, where m equals to mass, and ओमेगा क्या होता है, ओमेगा होता है, और ओमेगा क्या होता है, ओमेगा इक्वल्स टू एंगुलर frequency, right? So angular frequency omega equals to root over k by n. अभी क्या k क्या निकले थे ऊपर, angular frequency equals to omega equals to root over k by n. अभी क्या निकले थे k ऊपर, वो हम यहाँ पे पुट कर देते हैं, equals to q square by 2 pi n epsilon naught dq. So the answer is option number 1. Now let's start with another question from 24th February shift 2. A point charge of plus 12 microcoulomb is at a distance of 6 cm vertically above the center of the square of side 12 cm as shown in the figure. figure में दिखाया गया the magnitude of the electric flux through the square will be, if we consider the square as a part of the cube, क्या कर रहे हैं, क्या कर रहे हैं हम यहाँ पे स्क्वायर को क्यूब के एक पार्ट बना रहे हैं. सो लेट मी ड्रॉ ऑन क्यूब. ठीक है, तो each side is 12 centimeter, and the point charge lies 6 centimeter above from a square surface. So this is in the midway position of this, plus 12 microcoulomb. So this whole length is 12 centimeter and it is in the midway position, that is 6 centimeter, right? So flux, we have to find the electric flux through the square. So flux through any surface of the cube when the point charge lies at the center equals to q by 6 epsilon naught, as there is 6 sides of the cube, right? अभी q का वैल्यू कितना दिया गया, 12 माइक्रो कूलम by 6 epsilon naught equals to 12 into 10 to the power minus 6 by 6 epsilon naught. We क्या करेंगे, 12 by 6 equals to 2, 4 pi into 1 by 4 pi epsilon naught into 10 to the power minus 6 equals to 2 into 4 pi into 9 into 10 to the power 9 into 10 to the power minus 6. This is all about calculation. So the answer is 226.08. So we'll start with the next questions, in which it said that the electric field in a region is given by E equals to 3 by 5 E0 I cap and plus 4 by 5 E0 J cap Newton per coulomb. The ratio of the flux of reported field through the rectangular surface of the area 0.2 meter square, which is parallel to YZ plane, to that of the surface of area 0.3 meter square parallel to XZ plane is A is to B, where A को हम निकालना पड़ेगा. Here I cap, J cap and K cap are unit vectors x, y and z axis respectively. So यहाँ पे क्या दिया गया कि ratio of the flux through two surface is A is to B, and we have to find the value of A. Area of first is first surface is 0.2 meter square and area of the second surface is 0.3 meter square. So let's start. Let the area of first surface be, if we consider it a factor, for area factor equals to 0.2 I cap. I cap क्यों दिया गया, because ब्रैकेट में लिख देता हूँ, because it lies on x-axis and it is parallel to YZ plane. Okay. Next, let the area of second surface B, A of suffix B, second surface B equals to 0.3 J cap. अभी J cap क्यों? Because it is given in the question that it lies on y-axis and it is parallel to xz plane, right? अभी फ्लक्स का क्या फॉर्मूला है, for from electric flux theorem, you can say that phi equals to क्या होता है E vector dot A vector. अभी पहले हम फर्स्ट सरफेस के लिए फ्लक्स निकालेंगे, फिर सेकंड सरफेस के लिए फ्लक्स निकालेंगे, फिर दोनों को रेशियो कर देंगे. क्या करेंगे? देन phi of A equals to magnitude E dot A of suffix A equals to, अभी E क्वेश्चन पे क्या दिया गया था? 3/5 E0 I cap plus 4/5 E0 J cap 0.2 of I cap. A vector equals to 0.2 I cap for first surface. अभी equals to 3/5 E0 into 0.2, क्योंकि I vector, this I vector or this I vector, if they form the scalar product, then it becomes 1, and if I vector I cat dot product with the j cat, it will give 0. So we'll find 3/5 is 0 into 0.2, and phi of B equals to E vector dot AB vector, and it becomes 3/5 A0 I cap plus 4/5 A0 J cap 2.3 J cap, equals to 4/5. Similarly 4/5 into 0.3. अभी अगर रेशियो निकालना पड़ेगा, तो रेशियो phi A by phi B equals to A by B equals to 3/5 E0 into 0.2 by 4/5 A0 into 0.3. Again 5 cut जाएगा. After solving, I think everyone can solve this. E0 is 0. So we get A equals to 0.5 of this ratio. This ratio is already given in the question, that the ratio of the flux of A and B is equals to A by B. फर्स्ट सरफेस और सेकंड सरफेस के फ्लक्स की रेशियो अगर करें तो हमको क्या मिलेगा? A by B मिलेगा. So A equals to 0.5 of B. So here we'll start with another questions from 25th February shift 1. 500 identical drops, 12 identical drops of mercury are charged to a potential of 2 volt each. The drops are joined to form a single drop. The potential of the drop is how much? So we'll start like this. Let charge on each drop be q and radius be smaller for smaller drops. So we know the potential formula for electrostatics, which is given by V equals to kq by small r. K equals to 1 by 4 pi epsilon naught. Everyone knows about that. Now it is given that the potential of each small drop is 2 volt. Okay, so 2 volt equals to kq by small r. Now let the radius of bigger drop अभी कैपिटल आर। सो क्या होगा कि सारे छोटे 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 जितने भी ड्रॉप्स है वो अगर कंबाइन किए, मतलब कि 512 ड्रॉप्स इफ दे आर कंबाइंड, so they make the volume of the larger drops. So we can write that volume of large drop is equals to 512 into volume of each small drop. So volume of any sphere is given by 4 by 3 pi capital R cube equals to 512 into 4 by 3 pi small r cube, right? Or you can say that r cube equals to 512 into small r cube, or r equals to cube root of 512 small r equals to 8. Now, now क्या होगा, कैपिटल आर तो निकल गए, अभी क्या करना पड़ेगा, पोटेंशियल निकालना पड़ेगा, पोटेंशियल of larger drop, capital V dash, we consider it as V dash equals to K capital Q by capital R। अभी K को रहने दीजिए, फिर Q को हम क्या लिख सकते हैं, 512 ऑफ स्मॉल क्यू। स्मॉल क्यू क्या होता है, ईच स्मॉल चार्ज के वैल्यू। और कैपिटल R को क्या लिख सकते हैं, 8। अभी K Q by small r into 512 by 8, और के क्यू बाई स्मॉल आर हम लोग क्या निकाले थे, 2 वोल्ट इक्वल्स टू 512 बाई 8, अगर इसको 64 64 equals to 128 volt. So the answer will be 128 volt. So हम लोग को ऐसे करना पड़ेगा। I hope all of you like the video. Thanks for watching. Please like, share and subscribe our channel. Thank you.